Okay, in this last video lecture, we're going to talk about these following topics. So these are our objectives, if you will. The object initializers, overloading operators. We're going to have arrays of objects. So before we had arrays of ints, but now we're going to have an array of dogs or an array of cats or an array of people or whatever it may be. And then we're going to learn how to sort those elements in the array and how to search for a value within those objects within the array. So we're going to start off at the beginning here with object initializers. And I need to go ahead and build out this class. I just went ahead and created a public class animal. And for me to talk about object initializers, I need to go ahead and have some properties. Our animal class, and we'll use the shorthand for properties here. So I'll say prop tab tab, and all animals will have some number of legs. And for this, we'll say all the animals will have a name. Now, by convention, make sure that your properties are capital. So these, as we declared them before, these are auto-implemented properties. And I've had to remind a few students already, when you have the auto-implemented properties, the shorthand version like this, you do not declare the backing field. Notice there's none. I did not say private int num legs. Okay, this will cause problems, so I'm not going to declare that in your programs if you do the auto implemented. If you do the full-blown property where you actually declare a get and set block, then you still need those backing fields, the instance fields. But since we're doing auto implemented, we don't. So it's really a pretty straightforward class, and if I wanted to, I could have a method, but just to demonstrate object initializers, all we really need is properties to demonstrate an object initializer. Let me go into my program where I have a main. Here's our main method, and I will just comment out everything from yesterday and the day before to kind of start right here. And we can now declare animal A1 equals new animal, and this is nothing new. You would expect this to work. However, now that we have properties, notice we don't have any constructors here. Since we don't have any constructors, the default constructor will work, meaning the empty one. But inside of the constructor, actually, it looks a little different. We can use these curly braces instead. And inside of the curly braces, we can directly set the properties num legs equal to 2, comma, and then the name equal to, let's just say, whatever, our two-legged cat. Now, let's see. Of course, name needs to be a string. And that'll work. So, what's the benefit here? Well, you notice we didn't have to write a bunch of overloaded constructors. All we had was our properties, and directly through the properties, instead of using the constructors to assign the values, we can now use our properties to do the same thing. And as you might expect, if I do a console.writeLine, if I just print out the name of our animal, yeah, next row. Try that again. You can see the name of our animal is cat, and if we wanted to print out the number of legs, it'd be just the same thing. Go ahead and run it. And again, so it's all about putting data into our objects and getting it back out. And this example right here is how we use Object Initializers. Okay, so that's pretty straightforward. You can say that's done.
Is there a way to use that in?
So now we're moving on, and we get to define in programming. Let's start by saying this. Overloading operators. Well, first off, what is an operator? An operator is something like the minus sign, or something like the plus sign, or something like the time sign. And you may or may not realize it, but let's just take the plus sign as our example because that's what the book does. The plus is already overloaded, meaning it can behave different ways. For example, if I were to say 2 plus 3, we're adding integers together. However, if I were to say hello plus world, this adds strings together. So the plus symbol is overloaded, meaning depending on the values that are around it, that are meant to be added, it'll behave differently. This performs concatenation, where this performs addition. And so we have the ability now, as we begin to create these classes, we get to define certain things. What does it mean if you add two animals together? Well, you have to define that. It means nothing right now. But what if you were to multiply? Well, if you want to define that, you can define that. What does it mean if you divide two animals, or what does it mean that, if you use any of these operators on your class? You would get to define that. So, in our class, we have a number of legs, we have a name. Maybe if we were to add these together, maybe it would add to the total number of legs, and the names would concatenate. Again, you get to define what does it mean to add two of these particular things together. So let's do that, and the way that you do that is by writing a method, but it looks a little different. So I'm going to start by public static. We're writing a static method, and this method is going to return an object of type animal, and we're overloading an operator plus. And this operator is going to take two animals on both sides of it. So it'll take you know, when you're adding, it'll take two animals, one on the left, one on the right, similar to a 2 on the left and a 3 on the right here. So it looks very similar to a method, but this is how we overload this particular operator, the plus operator. And we might have int total legs equals first number of legs plus second number of legs. And then we will have string both names equals first name and return a new animal. And because we just learned about object initializers, I'm going to use an object initializer here. I'm going to say num legs equals total legs, comma, both name equals both names. So this is it really is kind of a strange example, but the purpose of it is to demonstrate, hey, we have the ability, should you need it, if we do need to define what does it mean to add our classes together. You get to define it. Remember, that's how it makes sense to me, because what does it mean to add two objects together? Well, out of the box, by default, it means nothing, but you have the ability to define it by overloading an operator. So if I were to go back to my program here, we already have an animal here, which is a two-legged cat. And let's breed them with a okay, that's weird, but we're gonna, sure, it makes sense. We'll go animal b1 equals new animal. And we're gonna use our object initializer. How many legs does our dog have?
Six.
It has 6 legs, and I guess we'll give it, what type of cat was this? We'll say Cheshire cat. Is that a type of
Only in Wonderland.
Cheshire? Is that spelled probably wrong?
Nope.
Cheshire cat. And what type of dog are we doing?
German Shepherd.
German Shepherd. Okay, so now we have two animals, a two-legged Cheshire cat and a six-legged German Shepherd. And the thing is when we add these animals together, it returns a new instance of a class. So we have to say animal, I'll just call this combo, equals A1 plus B1. Okay, so we have our new animal, and you can imagine on the left hand side we have this portion, on the right hand side equals new animal, just like we had before. That's what we're returning. We're returning what goes on the right hand side of that equal sign. So if I do a console.writeLine, we could say our crazy monstrosity yeah, it's probably bad, monstrosity has, and I'm going to say this many legs, and is a mix between, and remember this is the name, right? It's a mix between, it'll say Cheshire Cat space German Shepherd. And so this will be combo. That's the name of our combo number of legs, comma, combo dot name. Excuse me. So not too worried about our cat there. We got the cat, we've got the dog. We add them together into a different animal called combo and print it out. See, our crazy monstrosity has 8 legs. Remember, because we added the legs together, so 2 plus 6 is 8, and is a mix between Cheshire Cat space German Shepherd. Right, and so we've effectively done what we set out to do. I didn't mean to open room. If I go back and take one more look at this, and you can change this however you want. If you don't want, maybe by adding them together, you get the total number of legs, and then, I don't know, you divide it by 2. Maybe you do some different math in there. That's up to the business. That's up to the real world scenario. Obviously, we're making crap up here just to demonstrate how it can be coded, the syntax and the logic behind it. So that's overloading operators. Okay, now an array of objects. And this part has one tricky thing. Okay, when you're dealing with an array of objects, there's one tricky thing I think most new programmers need to see. So I'm back in my program, I'm back in main. And how do we create an array of objects? Well, our data type is now animal. I'll just call this my animal group equals new animal. And we'll have 5 animals in our animal group. Don't forget my first set here. There we go. So here, now we have an array of objects. Well, I'll say an array of type animal. Unlike an integer array and things like that. Now, each animal group, you might think at this point, I could say animal group sub 0 dot name. So the first animal is our snake. Okay. This would not work at this point because there's another step. This step creates the array. But the step that we've forgotten at this point, we must also create each object within the array. So when we say we create an object, here's something I haven't said yet, and I think you've probably read it in the book, but anytime you see the keyword new, the keyword new creates an object. Okay, now what we did in this particular thing is we created an array object, but we have not created any animal objects. So for example, we would have to say animal sub 0 equals new animal. Oops, animal group. My bad. Animal group is how we refer to the array. So animal group sub 0 equals new animal. That creates one animal object inside of an array. But how many are there? There's 5. So we have to say animal group sub1 equals new animal. Do you think there's a more efficient way than doing this? There's no such thing. What is that?
The loop group that doesn't exist.
Yeah. You guys know how to work with arrays and a loop. So instead of typing this all out, we'd write a for loop. For int I equal to 0, I less than animal group dot length, I plus plus. We can say animal group sub I equals new animal. Okay, now we're ready to start putting data into our objects because we've created the array and we've instantiated each object inside of the array. Now we could say something like animal group sub 3 dot name, you know, we'll start it off at 0. And of course it would make sense. Let's do another for loop. For int I, we don't even need another for loop. Animal group sub I dot name so console.writeLine, what's the name of animal I plus 1? So this will say, what's the name of animal 1? What's the name of animal 2? What's the name of animal 3, 4, and 5? And then you'll get the input from the console, and then you'll assign it to position 0. And how many legs does that animal have? And then you could say animal group sub I dot num legs equals convert to int 32 console.readLine. So we used a loop to instantiate our objects, then we start putting data into our objects that are stored within the array, and then I'll just have a simple for each loop var item in animal group okay, animals, oh my gosh, not thinking, animals name 0 has that many legs, and we will say item dot name comma item dot num legs. Just a little input output to demonstrate objects inside. So let's comment this, and so we can kind of follow along. What's going on here? Creating objects within the array. So we're instantiating objects of type animal inside of the array. These 4 lines, data in, we're putting data into the objects. And then this line, data out. And so I'm just going to do 3 animals instead of 5. So that when I demonstrate this, What's the name of animal 1? It's a snake. 0. Dog. 4. Cat. 2. Animals named snake has 0 legs. Named dog has 4. Animals named cat has 2 legs. Like my English.
Did you create those animals already? Like you create those names of, how does it know how many legs?
How does it know how many legs? Because right here, I assign it. I assign animal group sub I, that particular animal's number of legs, equal to whatever I type into the keyboard.
Oh, you typed in those.
Yeah, I typed it in. Yep. Yep. Yeah, I typed fast. Yeah. Okay, so that is what it means to overload the plus operator. Then we have now talked about the array of objects. So don't forget, arrays must be created with the keyword new. Then instances of your class must be created using each instance of the array with the keyword new, which is what I'm referring to right here. Animal group sub 0 equals new animal. Animal group sub 1 equals new animal. Animal group sub 2 equals new animal. I just happened to use that same for loop to put the data in. So animal group sub 0 has a name. Animal group sub 0 has a number of legs. Yeah. So this is the output. I use a for each loop. So each item will be each loop through the animal group array. So just a shorthand way, instead of having a full for loop, just use a shorthand for each loop. Coming back from a short break here, one thing I did notice on that break is I used the wrong word here, so I'm going to change this. You don't have an instance of the array. There's a bunch of elements of the array. So each element will become an instance. That is correct. Each element will become an instance. Now, next topic, on to sort and search. So anytime you have a bunch of information, such as we do now, we have these animals, and we could have 300 of them just like that. Okay, and so we have all these animal names, and all of these animals, they have different number of legs. All of a sudden, we've got a lot of data we're working with. And anytime you have a lot of data, you have to be concerned with, well, some basic things like, how do you search that data? How do you sort that data? Excuse me. And when we were working with arrays, we already did sort and search. And we've already done that. We've been tested over that. And we understood how that worked. But if you're sorting integers, it's pretty simple to sort integers. But if you're sorting an animal, it kind of goes back to what I said before. What does that even mean? What does it even mean to add animals? Well, we define that. Well, what does it mean to sort animals? Well, again, you got to look at their properties. Well, if we're sorting them, we can on these we have two options. We're either going to sort them by their number of legs, or we're going to sort them by their name. Those are your two options. So let's do that. Let's create a way so that if we decide we need to sort our animals in ascending order from the least legs to the most legs, we can do that. Now the book will go through and they'll give you some definitions here of what an interface is. But the way that we do that is we have to implement this interface called I'm just going to show you how to do it. Comparable. Okay? So we add this little bit of code to our class header. Remember we said this is our class header. And what an interface is a way of forcing behaviors. And I say that because if I hover over this, it says, hey, this isn't compiling because animal does not implement the compare to method. Show potential fixes control plus. I'm going to hit control or control dot. Hit control dot. And let's click on this. You see it added this method for me. Okay? So this is the method that when you use this interface, it's going to force you to write a certain method. The method is called compare to. It is going to essentially be the method that determines how we compare one animal to another. And if one animal is greater than another or less than another based on what we decide. We decided we're comparing them based on their number of legs. So let's delete this and let's write the logic. Now here's some theory here. Realize this returns an integer, right? This compare to method. If the int is negative, the instance is less than what you're comparing. If the int that you're returning is equal, the instance is equal to what you're comparing. If the int is positive, the instance is greater than the compared object. So basically what it means is this integer, if it's less than 0 or greater than positive, is going to basically determine how one thing compares to another. Essentially, you're going to be comparing all these animals by their number of legs. So you're going to be comparing one instance to another instance number of legs. Now this logic is going to be new to you if you haven't looked at this in the book. I'm going to have an integer return val, and that's going to represent what gets returned. So at the end of this method, we're going to return val. I'm going to create an animal called temp equals. Notice we have this object O, and we haven't talked about inheritance much, but what we're going to do is we're going to, oops, typos. This object is going to hold an animal object. This obj is going to reference an animal object, and we're going to store that in a variable called temp. Then we can say if temp dot, so you know that temp holds an animal because it has names and number of legs. If temp dot number of legs is greater than Oops, let's do this. We have to say this. If this dot number of legs, this meaning the first instance is greater than temp dot number of legs. So this is where we're doing the comparison. One instance of animal that is referred to as under this, another instance of animal that's referred to as temp. So this is comparing two different animals' number of legs. If one instance is greater than the other, return val equals 1. Else if this number of legs is less than temp number of legs, return val equals a negative. So if it's greater than, if it's less than, otherwise they're the same. And return val equals 0. And then we return val. Okay, so really the kind of the weirdness and the newness to this, whatever, is this line of code right here. And then realizing that we can compare one instance of an animal that's stored under a keyword this against another instance which has been passed in. How this method would be called, if we were to call this method, we don't call this method because this method is automatically called by sort. This method is used by sort. So when we write this method will be used by sort. So we don't have to call it. We just have to write the method to say, hey, when you're sorting, you have to sort by, in this case, the number of legs. If we were to do this, we could have like animal A1 and animal A2. And the way to compare these animals would be A1 dot compare to A2. So A1 would be the animal that is referenced under the keyword this. A2 would be the animal that gets passed into OBJ and that you're converting to temp. So that's kind of the method call so that you can understand what are the two instances that are being compared here. A1 would be this, A2 would be temp. You had a question?
Can you compare multiple, not just one, but like A2 and A3 and A4 at once, or is it just only
One at a time, or two at a time. Yeah, two at a time. All right. So now just realizing that the sort method is used compare to, let's go back into our main and let's actually call the sort method on our array. So we have 3 animals and they're going to sort by their legs. But what I'm going to do in here is I'm going to say array dot sort. And I'm going to pass in our array, which is animal group. So now regardless of the order that I put them in, they're going to be sorted by their number of legs. So I'll put them out of order as the data goes in, and then it will sort them, and then on the output you'll see they will be put out in the ascending order based on their number of legs. Okay.
Did you change it back from 300?
Yeah, I changed it back from 300 down to, changed it down to 3. Okay, what is the name of animal number 1? Again, since it's going to be centipede, that's close enough. And how many legs does it have? 100. And then we'll say snake has 0 legs and dog has 4. And you could see the output is not the same as how we put the data in. Snake has 0, dog has 4, centipede has 100. So sort this method uses compare to, and since we wrote the compare to method to compare instances against each other, returning values based on if one's greater than, less than, or equal, we now have the ability to sort our objects, which is a very cool thing. Then the last thing is to be able to search. Well, search also, for example, our binary search. Well, if you remember binary search, you have to have sorted data, right? Your data has to be sorted if you're going to search through it. So we can actually, since we've sorted our animal group, we can now use, let's just say int x equals array.BinarySearch. We're searching through animal group, and let's search for the value of 100, meaning 100 legs. And if it's found, it will return the position, which will be position 3 in our example. So if x is greater than 0, console.writeLine, we found the animal at position x. So notice we've hard-coded in the number just to demonstrate if this is going to work or not. Let's go ahead, let's put in a breakpoint just to see how this would work. I'm going to hit a breakpoint right here, debug, start debugging. Centipede has 100, snake has 0, dog has 4. We hit the binary search. Notice it goes into compare to. Okay. Let's figure out what's going on here, because I've done something wrong. Okay, I see my mistake. And in this case, we're looking for a number inside of an animal group, but we need to actually look for a particular animal. So we have an array. Let's create an animal. And we'll set the animal's name equal to centipede. Is it with an I or whatever? Num legs equal to 100. And then instead of searching for the number, we search for the animal. Let's start without debugging this time. See if it still crashes. CNTIPDE 100, snake 0, dog 4. There we go. It says we found the animal at position 2, which makes sense because this is 0, this is 1, this is 2. So we were able to seek for an actual animal. So instead of passing the number of legs, I jumped to that conclusion. I forgot you need to actually search for an actual animal object. So that would work. You could have an else statement, else you could say animal not found. And if we changed our random animal to a cat, right, that has 100 legs, and animal 2 was our snake, 0 legs, and dog 4. Because our number of legs is still 100, it still found it. Let's try number of legs to 101. Since it's only searching on number of legs, it still found it. Do that again. Name of animal number 1. Now the animal is not found. So it's interesting because we changed the name from centipede to cat. The cat still had 100 legs. It was still being found in that position. But if you change the number of legs, because really that's what the iComparable is doing. iComparable is used not only by the sort, which we demonstrated, it's also used by binary search. And because it's used by binary search, we're telling it to search only for the legs. And because the number of legs was 100, the number of legs was 100, it was finding it. Otherwise, it would not. Show the what? Yeah, here's a compare to right here. Okay. The last thing I'm going to show you guys, and this is a lot of theory, more so than actually you won't need to do this at this point. So I'm going to add one thing. We showed you certain binary search. The last topic is destructors. And the theory behind destructors is that when an object is in memory, just before the object is cleared from RAM, a destructor will run. So a destructor is a method. And so if you put this all together, right, a destructor is a method that will run right before your data is cleared out of RAM. Now think about this in the terms of your English paper, right? You're sitting there, you're writing your English paper, and you're typing it up, and you've typed up a full page. You have 1 page of data on your Microsoft Word English paper. Where in your computer, where is that Word document stored at that point? Is it stored on the hard drive?
It depends on if you saved it yet or not.
You have not saved it yet. So the scenario is you have not saved it. Is it saved on your hard drive? No. Where is it saved? Where is that information stored at?
In Microsoft Word.
It's stored in RAM. Applications, programs, they run out of RAM until you save the data. So okay, so you're typing up your Word document. We know that all that information is saved in RAM, which is temporary storage. Let's say you just click the X, right? Here's the X. You click the X. What does it ask you to do?
Save.
Do you want to save your data? Okay? That's the purpose of a destructor. The destructor is, hey, this information is about to be cleared out of RAM. Do you want to save? Okay? What do you want to do before this data is gone? Okay? So that's generally the idea. Now destructors, I say save. You know, the book will call them cleanup tasks. Okay? Because it's actually more broad scoped than just saving your data. It could be save your data. It could be a closing a connection to a database. It could be closing a connection to a file. Okay, destructors generally, I mean, the broad way of defining it, perform cleanup tasks. And they look very similar. They look kind of similar. This is a destructor. So you would write whatever logic you need to do to perform cleanup tasks. Okay? And I just wanted to introduce you to this. It's more theory than hands-on, but realize that before any instance of animal would clear out of RAM, it would run this destructor. Okay, so you don't lose your data or what have you.
Like prompt you and say something?
It won't prompt you unless you tell you, you know, you could do a console.write line, right? You tell it what to do, you know. This is your prompt, you know, and then tell it what to do.
If you don't have a prompt, what would the point of having one be?
Well, again, it's kind of the same thing. Okay, let's say you've created an animal object and it's about to be wiped out of RAM. Maybe you want to save that data somewhere, right? So if it hasn't saved at that point, for whatever reason, if it hasn't been saved, maybe in your destructor, you write the logic to save your data somewhere. Okay, all right. And that actually brings us to the end of chapter 9. So that's where the video will end, and we're off to labs.